Hello class, today we're going to continue on with chapter 3 of section 1, using and expressing measurements. Today we're going to continue on with the significant figures and calculations, so sig figs and how we use them in calculations. So in general, a calculated answer cannot be more precise than the least precise measurement. So whenever we do anything, we're always going to do least precise. Now, the calculated value has to be rounded to make it consistent with the measurements that we made when we calculated it. So the first thing we have to do is look at rounding first. So to round a number, you must first decide how many sig figs the answer should have. And this decision is going to depend on the measurements that you took in lab and on the mathematical process used to get that answer. So what I mean by mathematical process is, did you add, did you subtract, did you multiply, or did you divide? And once you know the number of sig figs your answer should have, you're going to round to that many digits, counting from the left side. So if the digit immediately to the right of our last sig fig that we're allowed to have is less than 5, basically it's simply dropped and the last value stays the same. So we know that less than 5 stays the same. If the digit is 5 or greater, then we need to round up by 1. Hopefully you've been rounding since junior high, so less than 5 stays the same, greater than 5, round up by 1. So what we're going to do is we're going to round off each of these measurements to the number of sig figs shown in parentheses. So right here we have a number, and we want 4 sig figs. So what you do is you count from the left, like on the previous slide. So here's my leftmost digit. Here's 1, 2, 3, 4. So here's my last digit I'm allowed to have. So what you want to do is look at the digit right behind it. So can this 2 round up the 7? Since it is less than 5, it cannot. So hopefully 314.7, since if it's less than 5, it stays the same, is your answer. On letter B, again, we need 2 sig figs. So we're going to start from the left. So here we have 0. It's not our first non-zero digit, so we can keep it. 0, 0. The reason we can keep those is because they're place values. They don't count as sig figs since they are leading zeros. So they don't go towards that 2 count. So right here is our first sig fig, so I can have 1 sig fig. 7 is my second sig fig. So this is the last digit I'm allowed to have. So now I need to look, can this 7 round up this? So this is greater than 5, so yes, it rounds up it to 1 up, which is 8. So this should be your answer. And then you have 8,792, and I just want 2 sig figs. So what you're going to do is you're going to start at the left. So here I can have the 8, that's 1 sig fig. And here's my last sig fig that I'm allowed to have. So I need to look, can that 9 round up that 7? And in fact it can, so it rounds up to 88. Now a lot of people just want to leave their answer as 88. And this is where you run into trouble with rounding. 88 is the tens place. 8,000 is the thousands place. So we need to tack something on the end so they have the same place value. Whenever you have to round up, these numbers that you drop off on the end become zeros. Now, since they're trailing zeros and there's no decimal, these do not count towards my sig fig count. But see how the place value is the same? They both go to the thousands place. So let's actually look through that step by step. So starting from the left, count the first 4 digits that are significant. And the arrow points to the digit immediately to the last one. Since 2 is less than 5, you do not round up. So again, yes, we did get that answer. And then here they just put it in scientific notation. On B, we counted from the left the first two digits that are significant. So like it says, first two digits that are significant. So we can just bypass those zeros since they're leading and they don't count. The 7 is greater than 5, so we round up. And we did. We got this answer. And then on letter C, we counted the first two digits that are significant. So we have to keep the 8 and the 7. The 9 rounds that up. And then again, like I said, please don't forget to do this on your worksheet. If you have to get rid of numbers at the end, they switch to a 0. So before we continue on, make sure that you understand that stuff. If you do not, join my Google Meet, email me questions, and I will try to help you to the best of my ability. Now we're going to go into sig figs whenever we add and subtract. So adding and subtracting are going to have different rules than if you're multiplying and dividing. So to answer an addition or subtraction calculation, it needs to be rounded to the same number of decimal places, not digits. And we want the least number of decimal places. So this you don't have to look and see if something has sig figs or not. We want to do decimals. So here are two good examples that the book uses. So we're going to go through each of these. So on letter A, what they did was they took these numbers and lined them up. What I like to do is here there are 2 after the decimal. So 2 after the decimal. Here there's 1 after the decimal. And here there are 2 after the decimal. When you calculate your answer, you get 369.76. However, it has to go to the least number of decimal places, so it can only have 1 digit after that decimal. So you have to look, can this 6 round up that 7? And it can. So you'll get 369.8 meters. So let's see if that's what your book got. So the second measurement has the least number of digits. It's only 1 to the right of that decimal point. So the answer can only have 1 to the right of that decimal point. And again, it got the same thing we did, 369.8. Or if you want to put in scientific notation, you can, but you are not required to. Here's example B. Here they lined them up. So again, if we look how many are after the decimal, 1, 2, 3. This one has 1, 2 after the decimal. So even though I add them and I get 46.286, I can still only have 2 because that's the lowest number. So here's my first 2. I need to see if that 6 can round up the 8, and it can. So 46.29. Let's see if they also got that same answer. So the second digit has only 2. So when you round it, you should get 46.29. People often confuse that rule for adding and subtracting with the multiplication and division rule. So first, make sure what order of operation you're doing, and then match the rules. Don't get these rules mixed up. So multiplication and division have their own rules. Instead of by decimal places, multiplication and division does it by the least number of sig figs. So the position of the decimal point has nothing to do when you multiply and divide. So let's look at these following examples, and we're going to go by them step by step like we did on the last one. So letter A. My second measurement is 0.34, and it has 2 sig figs. So this one, 7.55, has 3 sig figs. 0.34 has 2 sig figs. So even though I multiply it and I get 2.567, I can only have 2 sig figs. So here 2 counts as 1, and then here is my last one. I have to make sure, can this 6 round up this 5? Since this is bigger than 5, it can, so your answer is 2.6. For example B, you have to look, how many sig figs does 2.10 have? Well, it has 3. The 0 counts because it's trailing and there is a decimal. If you look at 0.70, it has 2 sig figs because this is, even though this is a trailing 0, there's a decimal, so it counts. This one's a leading, so it doesn't count. When I multiply those two, I might get the answer 1.47, but my answer can only have 2 sig figs. So I have to do 1, and I have to keep this 4, but I got to see if this 7 can round it up. And it does since it's greater than 5, so my answer is 1.5. Example C, if I were to look at this first measurement, there's 1, 2, 3, 4, 5 sig figs. If I were to look at the second one, there are 2 sig figs. So even though when I divide it, I get this big long number, again, I can only have 2 sig figs. So here, this one counts as my first one. The 9 will count as my second. I have to see if that 1 can round it up, and since it's less than 5, it cannot. So my answer stays 0.29. And the last example is if we were looking at 0.365, it has 3 sig figs. This 0 is a leading, so it does not count. If I were to look over here, this one also has 3 sig figs. These are leading zeros, so they can't count. However, these zeros on the end, the trailing ones, do count because there is a decimal. So when I divide these, I get 18.25, but I can only have 3 sig figs. So I keep the 1, I keep the 8, and then 2 is my last one I'm allowed to have. I have to look at this 5 and see if it can round up. Since this is 5 and greater, it rounds up to be 18.3. So that's the end of section 1. I know we split it into a lot of parts, but let me know if you have any questions, and I hope you have a good day. Bye.